In this example, we're going to be modeling cost, revenue, and profit analysis. J&W Lumberyard has fixed costs of $7,286.20 per day and variable costs of 65 cents per board foot produced. Lumber sells for $2.35 per board foot. So how many board feet must be produced and sold daily to break even? Well, let's first begin by filling in our chart here so we can identify our correct values. So first, let's identify fixed costs. Now recall the fixed cost is a cost that a business incurs. It's the expenses that are the same no matter how many units of a good are produced. For example, like the mortgage payment or property taxes and so forth. So what is our fixed cost here? Well, if you notice in the first sentence, it told us that we had a fixed cost of $7,286.20. So we can go ahead and put that in. Next, we want to identify our variable costs, and recall the variable costs are the expenses that change with the number of items that are produced. So in other words, the more items that you have to produce, the more it's going to cost you in terms of materials and so forth or whatever. So yes, that is what we consider to be our variable costs. It changes based on the number of items produced. So what is our variable costs? Well, we were told that we have a variable cost of 65 cents per board foot. So let's go ahead and put that in. And then lastly, we want to identify what is the cost of the item. And so if you read there, it says that the lumber sells for $2.35. Now to find the break-even point, recall that the break-even point is going to be the point to where there's no profit and there's no loss, to where you didn't lose any money and you didn't gain either. It's just break even. So to do that, you're going to have to set the cost function and the revenue function equal to each other. So your cost function, recall, is going to be your variable costs plus your fixed costs. And then your revenue is going to be the price of the item times however many items that you sell. So let's go ahead, now that we've identified what our fixed, variable, and price of the item, let's go ahead and set up our equation to where we set our cost function equal to the revenue. So our cost function is going to be 0.65x, that's our variable costs, plus our fixed costs of $7,286.20. And on the right side, we have our revenue costs, which is the price of the item times the number of items we sell. So since we don't know that, we just put an X to represent that. So now we're ready to go ahead and solve this equation. So to solve this, we're going to go ahead and proceed by subtracting 0.65x from each side because we want to combine our variable terms together. That's going to give us 1.7x on the right side. Last step to solving this equation for x is to do what? Yes, I'm going to divide by 1.7. Whatever you do to one side, you do to the other. And x equals 4,286. That means that that is the break even point, 4,286. But in order to make a profit, this company is going to have to make at least 4,287 or more to make profit. In other words, if it makes at least 4,286, they'll break even, no loss, no gain. You make more than that, then of course is a profit. Less than that, you occur the loss. So we were asked here the break-even point, and again the break-even point here is a 4,286 board feet. And there you have it.